Welcome to DBMS course. In this session, we will discuss about key constraints. So let us start the session. What are key constraints? According to key constraints, no two records of the relation should be same. That is, no two records of the table should have same values for all the attributes. For example, suppose we have a relation with 4 attributes: SID, name, class, age. So with respect to key constraints, no two records of the relation should have same value for all the attributes. If we observe the records of this relation instance, no two records are same. That is, no two records are having same value for all the attributes. So this relation instance is satisfying our key constraints. For example, suppose we are trying to insert a new record with attribute values 2, Sridhar, 2 and 32. Now the second record and the record which we are trying to add, both are same. So if we insert this record to the relation instance, it will violate key constraints. So according to key constraints, the insertion of this record is not allowed because it is having same values for all the attributes as in second record. Is it clear, sir? The next one is candidate key. What is a candidate key? Minimal set of attributes which can be used to differentiate records of the table. Minimal set of attributes which can be used. So for example, suppose we have a relation with attributes Aadhaar, name, age, city, PAN. So as per our knowledge, Aadhaar number is not same for any two persons. So we can use Aadhaar number to differentiate any two persons. So that means the attribute set or the set with attribute Aadhaar can be used to differentiate any two records of the relation. Now the second point is whether it is minimal set of attributes or not. Since this set is having only one attribute, surely it will be the minimal set of attributes. When the set is having two or more, then we need to verify whether it is minimal or not. But here we are having only one attribute. So surely it will be a minimal set of attributes. And it also can be used to differentiate the records of the table. So this is an example of a candidate. Is that fine, sir? Similarly, what about PAN number, sir? PAN number is also not same for any two persons. So that can be used to differentiate any two persons. And this is the minimal set. So this is also an example of a candidate key. For example, suppose we have a set with Aadhaar number, comma, name. Now this set of attributes can be used to differentiate any two persons or any two records of the relation, because Aadhaar number is enough to differentiate any two persons. So I can say they can uniquely identify. They can uniquely identify. Now the question is whether it is minimal set of attributes with this property or not. Okay, if we observe here, Aadhaar number is sufficient to identify any two persons. I mean any person uniquely. So this is an extra attribute. This is not compulsory for our purpose. So this is not a minimal set of attributes. So this is not a candidate key. This cannot be a candidate key because it can be used to differentiate, but it is not a minimal set. Is that clear, sir? Then in the previous example, we have some knowledge about the attributes of the relation. Now let us suppose that we don't have any domain knowledge about the relation. Then how to identify the candidate keys? We have mainly three ways to identify candidate keys. The first one is with assumption. While defining the relation schema of the relation, we make some assumptions. By using that assumptions, we can identify what are the candidate keys. And the second one is with instance. When they given the relation instance of the particular relation, we can identify what is a candidate key. And the last one is with the use of functional dependencies. So when they given some set of functional dependencies, which are holding on that particular relation. Using those functional dependencies, we can identify what is a candidate key. So now let us discuss each of these methods one by one. The first one is with assumption. How to find candidate keys with assumption. While we design the relation schema of the relation, we assume some assumptions. For example, we have a relation with 4 attributes: SID, class, age, name. So while defining, I will make an assumption that no 2 records should have same value for student ID. So in such cases, I can say SID is a candidate key. For example, suppose we have a relation with PID, project ID, project name, team lead, location. When we design, if I assume no 2 projects are having same ID, so then this can be a candidate key. Similarly, if we assume or we make an assumption that no 2 projects are having same name, then this also can be a candidate key. Is that clear, sir? The next one is with instance. How to find candidate keys when they given instance of the relation. Okay. The first one is first identify what are the attributes of the relation. In this example, we have 3 attributes. Is that clear, sir? Now try to write the possible sets of attributes. So what are the possible sets of attributes, sir? I can write set A, or I can write set B. We can write set C, or we can write set with 2 attributes. One is AB, one is AC, and the next one is BC. And what about set with 3 attributes, sir? We have this one. Okay, so this is the first step, sir. After that, candidate key is the minimal set of attributes which will identify the records uniquely. So we need to start from the minimal set of attributes. So first we try any one of these sets, that is the sets with 1 attribute is a candidate key or not. Okay, per suppose that this is A is a candidate key, then these 2 cannot be candidate keys, because why, sir? A is already enough or sufficient to identify the records uniquely. So B is an extra attribute, so it cannot be a minimal set. So that's why whenever A is a candidate key, no need to verify the supersets which consists of this attribute A. Is that clear, sir? Assume that these 2 are not candidate keys. These 2 are not candidate keys. Then in this set, B is not a candidate key. That means B is not enough. Similarly, C is also not enough. Then we can verify, because this will be minimal. I don't know whether it identifies the records uniquely or not, but surely it will be minimal. Why? Because B is not a candidate key and C is not a candidate key. Now I verify. If it identifies the records uniquely, then I can say it is a candidate key. Is that fine, sir? So now let us try for this example. So first let us try set with A. So go to the attribute A. Okay, verify whether any 2 records are having same value for the attribute A. If you observe this one, record 3 and record 5, both are having same value. That means if I call the records with the attribute value A2, 2 records will respond, sir. That means the attribute A is not able to differentiate record 3 and record 5. So this cannot identify the records uniquely, whether it may be minimal or not, but it is not satisfying our unique property. So that's why this cannot be a candidate key. So now the second one is B. So let us verify whether the attribute B is able to identify the records uniquely or not. So what about attribute B, sir? If you observe this one, B1, B2, B7, B3, B4. So all the 5 records are having distinct values for the attribute B. So if I call the records with the attribute value B, okay, only 1 record will respond. So that's why it can identify the records uniquely and it is minimal. So it is an example of a candidate. What about C, sir? Sir, a relation can have more than 1 candidate key. So B is a minimal set which can identify the records uniquely. So it is an example of a candidate key. C can also be like, right? So let us verify C also. So what about C, sir? C1, C4, C3, C5, C2. So all the 5 values are distinct. So it can also identify the records uniquely. So this is also an example of a candidate key. Is that fine, sir? So this is our first set. Now I need to verify whether this is a minimal set or not. Okay. Now please observe here. B is already a candidate key. That means B is enough to identify the records uniquely. So A is an extra attribute. So this cannot be a minimal set. Surely it will identify the records uniquely, but this cannot be minimal. So no need to verify, sir. It cannot be a candidate key. Why? Because, sir, some part of it is already a candidate key. Similarly, what about A, C? C is already a candidate key, sir. So AC cannot be a minimal set. So that is not a candidate key. What about BC, sir? Here B, C both are on their own, they are candidate keys. So this cannot be a candidate key. Is that clear, sir? So what about the last one, sir? Set with attributes A, B, C. Sir, B is already a candidate key. How can this can be minimal? So it will not be a candidate key. Is that clear, sir? So now let us do one more example on finding candidate keys. Find the candidate keys for the following relation. Though this relation is having 3 attributes. Now let us try one by one. What is the first set we need to try, sir? A. Okay. Go to the attribute A. A1, A1. So that means record 1 and record 2 both are having same value for the attribute A. So the attribute A is not able to differentiate record 1 and record 2. So this cannot be a candidate key. What about B, sir? B1, B2, B1. So record 1 and record 3 both are having same values. So attribute B is not able to differentiate record 1 and record 3. So that's why it cannot be a candidate key. What about C, sir? C8, C4, C2, C5, C3. So all are 5 distinct. So it can differentiate the records and this is minimal. So it is an example of a candidate key. Is that clear, sir? So now the next set. A, B. Before verifying whether any set is a candidate key or not, first verify whether any subpart or subset of that attribute set is already a candidate key or not. In this case, A is not a candidate key, B is not a candidate key. So it can be minimal. It is minimal, but I don't know whether it identifies the records uniquely or not. That we need to verify. So now consider the attributes A and B. Consider the attributes A and B. What are the values, sir? A1, B1, that is fine. A1, B2. So this is distinct. A2, B1, this is also distinct. A2, B2, this is also distinct. A2, B3. So all the 5 records are having distinct values for this set of attribute set. So it is minimal as well as it is able to differentiate the records. So this is an example of a candidate key. What about the next one, sir? A comma C. Is it needed to verify it, sir? No, because C is already a candidate key. Whenever C is already a candidate key, it is enough to identify the records. Why we need extra attribute A? So this cannot be a minimal set. So this is not a candidate key. What about next one, sir? B, C. With the same logic, since C is a candidate key, this cannot be a candidate key. What about next one, sir? A, B, C. The same story, sir. C is already a candidate key, so this cannot be a minimal. So that's why it is not a candidate key. Is it okay? So the next example. Find the candidate keys for the following relations. So we have 3 attributes, sir. Let us solve it quickly. So for the attribute A, record 1 and record 2 both are having same values. So it is not a candidate key. What about attribute B? Record 2 and record 4 or record 1 and record 2 both are having same values. So it cannot be a candidate key. What about C, sir? Record 1 and record 3 both are having same values. So they are not candidate keys. What about A comma B, sir? A1 B1, A1 B2, A2 B1, A2 B2, A2 B1. So record 3 A2 B1, record 5 A2 B1. Both are having same values for this attribute set AB. So it is not able to differentiate record 3 and record 5. So this cannot be a candidate key. What about A comma C? What about A comma C, sir? Let me write the values here, sir. A1 C2, A1 C4, A2 C2, A2 C3, A2 C3. These two records are having same values. So it is not able to differentiate record 4 and record 5. So this cannot be a candidate key. What about the next one, sir? The next one we need to try is the set with B comma C. Consider the records B1 C2, B2 C4, B1 C2. So please observe this, sir. B1 C2, this is our third record. B1 C2, this is our first record. So this attribute set is not able to differentiate record 1 and record 3. So this cannot be a candidate key. So now let us try with attribute set with 3 attributes A, B, C. Okay. Now one important point to note is if I consider all the attributes of a relation, surely it will identify the records uniquely, or it is able to differentiate the records uniquely, because according to key constraints, no two records should have same value for all the attributes. So when we consider all the attributes of a relation, surely it is able to differentiate the records, but we don't know whether it is the minimal set of attributes or not. Okay. In this example, please verify it. No subset of this set is a candidate key. That means no subset is able to differentiate the records. Okay, so that's why it is a minimal set. So it is a minimal set, and as well as it is able to differentiate the records. So that's why it is a candidate key. Is it okay? Properties of candidate keys. So now let us list out some properties of the candidate keys. The first one is if X is a candidate key, then no two records in the table should have same values for X. Okay. For example, assume this is my candidate key. If these two records are having same values for the attributes of X, then the X cannot be differentiated, or the X cannot differentiate these two records. If it cannot differentiate two records, how it can be a candidate key? So whenever it is a candidate key, surely no two records will have same values for the attribute set. The next one is if X is a candidate key, then proper subset of X should not be able to differentiate the records. Okay. If X is a candidate key, for example, AB is a candidate key, then proper subset, that means suppose I consider the subset A, then this cannot differentiate the records, because if this can differentiate the records, this cannot be minimal. If this cannot be minimal, I cannot say it is a candidate key. Since it is a candidate key, surely it must be minimal. Since it is minimal, A should not be able to differentiate the records uniquely. Should not differentiate the records. Is that clear, sir? So whenever I have a candidate key with two or more attributes, if I consider some proper subset of that particular candidate key, it should not be able to differentiate the records of the relation. The next one, a relation can contain more than one candidate key. We have seen so many examples. We got two or more candidate keys in the examples. So that is about key constraints. In next session, we will discuss about types of keys. Thank you.